Hello and welcome everyone. About ready to get started here. Good to see a nice group of people online. We got some interesting stuff to talk about today, so I'm pretty excited. Let's get started right away because we got a pretty full slate of things here. I know a lot of people that are here today have already seen presentations of mine. I also see that we have quite a few people that are first-time attendees. So I'd like to take a moment to introduce myself real quick. My name is Marcus Egger. I'm the President and Chief Software Architect of Code and all the different Code group members, which we have a slide about here. Code is a organization at this point that deals with a number of different things that are all dealing with things related to coding. And I have my microphones a little low, so I'm gonna put that up a little higher. Hope that's better. So anyway, Code is here to help you build better software, whether that's through our consulting, training, magazine, staffing divisions, online events, live events. So that's what we are doing. And I've been instrumental in this, I would say. I've been the guy who started a lot of that. And I have all my helpers here today that are helping me or are often doing these presentations. So that's what I do. I'm a Microsoft Regional Director, which means I have a formal relationship with Microsoft, but I do not work for Microsoft. I want to make that very clear. So I can say whatever I want to say. I don't have to stick to Microsoft or anyone else's marketing shtick. And as people who know me know that I often like to do exactly that, speak my mind. So that's what I'm here for today, to give you an honest opinion, to share some of my experiences we've made with the topic at hand. We've now spent quite a bit of time with artificial intelligence and especially large language models and how to talk to them and how to get the best out of them. And that's what we want to talk about today. Now, I don't have my usual intro chief here today. Jim is out on a vacation, so I'm doing my own intro. He tells me I have to do a few marketing slides. I'll do that very, very briefly. Just a little information about what we do as a company. Most people know us for Code Magazine because that's the most visible thing we're doing, as well as a lot of these online events. But we are at heart a consulting, custom software and staffing organization. So consulting can help you with all your needs. After all, you know, we're doing these free events to get the word out. So if you have any needs on any of this, please don't hesitate to call us. I always tell people, consider us a resource. If you have any questions, feel free to email me or our info email address. We're not the kind of company that'll send you a bill for an email answer if you have a technical question or something like that. Now, one of the things I specifically want to draw your attention to, because it's very relevant for what we're talking about here today, and that is what we call our executive briefings for AI. We've been doing quite a lot of these for very large organizations, but also smaller organizations. And the goal of this is to connect with organizations and tell the leadership of organizations what AI can do for them. So specifically, what are the expectations you should have with AI? How can it be useful for your business? How can it be correct in what it produces for your business? How can it make you more productive? What are the dangers? So we're doing these executive briefings. We have two different versions of them. Normally, when we do executive briefings, they include a pilot project. They include fairly lengthy meetings if need be, to really get across some beefy information. That's a package that we charge for a few $1,000s. You can look at it on codemac.com/executive briefings. But we also have a smaller version of that, which is essentially a meeting where we tell you a lot about what's going on, but there's no follow-up projects or anything like that. So that we do kind of under our free hour of consulting. So if you're interested in that, we can set that up for you or an organization that you're dealing with, and doesn't necessarily have to cost you anything for the smaller version. Like I said, we're doing a lot of those for free. So contact us about that. Check out those URLs. You might have questions after this. And since you came to this presentation, I want to extend this offer to you where you can take advantage of the service without having to get charged for it. So that's that. The other thing I want to point out is a newer part of our business, which we've been doing for a year and a half or so now, or a year on high speed, and that is code staffing. We set out to disrupt the staffing industry to set a better standard for hiring people, employing people, to give companies access to Silicon level style talent on the client side. And it's become a very important part of our business that's growing very, very fast and has been an exciting thing to do. And we are happy to see that it's already changing the way other staffing organizations hire people and treat people better, because that's one of the main things we set out to do. So from an employee's point of view, a cool thing, there's another slide here. We're looking for people badly. So if you're looking for jobs in the tech industry, check out codestaffing.com/careers. And if you're a company that needs people and has difficulty getting the talent you want and employing them in a way that treats people well and gives them good benefits and training and all career development, all those things, it's a cool thing. Anyway, so that's it pretty much for the marketing. We have more of these events coming up. We have training classes scheduled. We got State of .NET classes that are scheduled that will be announced in the next few days. We have a live tour for State of .NET. State of .NET we have two webinar and event series, Co-Presents and State of .NET. And so we are planning a State of .NET tour in person. We'll announce some details this in the next few days. We'll also have a State of .NET online event again for .NET 8 in November. And of course, we have more Co-Presents events that will also be announced over the next few days. We're pretty much doing this on a monthly schedule now. And of course, all these things are completely free of charge. I'm not selling you anything here. It's just cool information. You also get you're entitled to a free subscription if you came to this. I'm not even going to spend a lot of time on that. Slide decks and recordings. We are going to send you a link to all of this after the event. You're going to get a follow-up email, and you can download all the slides. You can get access to the recording of this. You can get access to the recording of prior Code Presents and State of .NET sessions as well. And again, all free of charge. So that's that. And then I do have a favor to ask, and that is, it really helps us if you fill out your event survey, because it tells us the topics that you're interested in, tells us what we should do in future events. And so you could do me a huge favor. It's just a handful of questions, 12 questions, doesn't take very long. And this, by the way, the URL will be repeated at the end of the slides, and we'll also send you this, like I said, as a follow-up where you can download it. So I'm going through this relatively quickly. Some of those slides are just in there, so you have them after the fact. And finally, before we get into the topic at hand, I wanted to thank you for attending. I don't do that enough. We have a ton of new attendees here. We have repeat attendees. The signups are approaching, I think, 2,000 people, and we have multiples of that watching the recordings afterwards. So awesome. It's interesting to see, and that's why I wanted to share this with you, how much excitement there is around artificial intelligence. And if you've seen a presentation of mine in the past, you know I'm super excited about this. It's the most fun I've had in my career that's been over 30 years now. And thank you for the repeat attendees. I've seen we now have several people that attended more than 50 of our events. So awesome, welcome back. Somebody's close to 60, I think 58 or something like that. So that's fantastic. And anyway, we're going to have some fun, and thank you for attending. It's been great to see you guys. So what are we going to talk about here today? We're going to talk about how to talk to an AI. And that in particular means large language models. So we are mainly talking about AIs that produce in a generative way text output. So that's what everybody's talking about these days. That's what we're talking about here. There's other AIs, of course, and we'll have Co-Presents about that in the future. But today it's all about LLMs. We're talking about prompt engineering. Prompt engineering means something different whether you're a developer or a user. We'll cover all that. Everything that we'll talk about here today should be useful for developers, and most of it also for users. There's an example or two where it requires development, but for the most part, we are just talking about how do you talk to an AI to get the best out of it. We're talking about some, what we would currently at least call advanced scenarios. We are not that far in with all of this. So we're at the beginning of talking to LLMs. But for that, I think we'll have some advanced scenarios. And again, what I want to share with you today is what we've learned in a lot of real world examples, because we are building real world apps with this. We have been doing that for a little while now. And so we've learned a lot about things that work and things that don't work. And that's what I want to share with you here today. So let's set some basics. I know some of you already know this, but I also know a lot of people are new to this. So I have to spend just a few minutes setting up some basic expectations and understand what we are talking about. So what are large language models, or LLMs? They are a special kind of AI that deals with language. So fundamentally, what we are talking about is an AI that you can talk to and that can respond in a meaningful way. So much so that we are fooled very often into thinking it's truly intelligent. It's actually not. It's statistical math and probability calculations turned into text, but it looks very, very convincing to a point where some people start wondering if those large language models are in fact conscious. And I would say they're not. I guess the question is human consciousness really that much more? Is it really this magical thing that we always think? But what we're basically talking about is machine learning models that employ statistical math on an extremely large scale and use it to produce interesting text results. So we are talking about making the computer understand spoken word or written word and respond in a meaningful way. We are teaching it how to speak and a little bit how to think. Now, doing that implies that these models have a certain understanding about the world, because the text that we are training those models with is based on things that happen in the world. In fact, those language models are trained on pretty much any text that's available freely on the internet in any language that it might be available. So that implies that if I ask, say, the model about, tell me what the Star Wars movies are all about, they happen to know what the Star Wars movies are about. But at the end of the day, that's more coincidental and a side effect of teaching these models how to talk and how to respond. So in many cases, our expectations that they will just be factually correct, that's not really realistic. What we really need is we need to teach these models actual data on top of it, and we'll talk about some of that today. So that's what you're talking about, these large language models. And language models, large language models have been around for a long time. Everybody who has a cell phone has used the cell phone keyboard, and in the cell phone keyboard there's a large language model that helps you type. Those are, as far as large language models go, pretty small large language models that are based on relatively simple mechanisms, but they are a first example of that. Now, we could go into detail as to how these even bigger language models work. So, ChatGPT being the prime example of a large language model that really got everybody's attention. Those are more sophisticated, but they all work based on these statistical calculations. And in fact, if you're interested in how these work, I'm not going to go into a lot of detail here today, except for some basics that we need to understand. But I encourage you to go back to the last Co-Presents presentation we did, where our own Dr. Otto Dobertsberger did a presentation on how do these things work under the hood. And the recording's available free of charge, and we'll send you an email link to that as well. But here are some of the basics that we have. If we were to train our own large language model, we could do something like this. Here is a poem from Bob Dylan, and in this poem we have a little bit of text. So now let's say we want a large language model that can create poems in the style of Bob Dylan. Well, we could take what he has written, analyze it statistically, and then produce an AI that can basically talk the same way. So we go through this and we would say, oh, well, he uses all these words. He uses the word you a lot. And in this case, we have 5 instances of the word you. And then we could analyze this further and we could say, well, after the word you, what else comes afterwards? And what's the statistical probability of that? And so we could now go through this and we could assign statistics, and then we could repeat this for every word, and we could do this for everything Bob Dylan has ever written, and we could do layers upon layers of that. And at the end of the day, we'd have a statistical model that tells us probabilities as to what word follows after another word. And now we could ask this large language model to say, hey, write a poem about whatever using these probabilities, and it would spit out something that might sound a little bit like Bob Dylan. Now, we have to do this on a very, very large scale. So GPT-4, for instance, took months and millions, I think, in fact, hundreds of millions of dollars to train. but it's more of the same. And if you're interested in how a lot of this works, go and watch Dr. Otto Dobertsberger's presentation as he goes into a lot of detail. For us today, what's important to understand is when we deal with large language models, what we are creating is we are creating output where we take something and then we predict what the next most appropriate text is that goes with what we are generating. That's the very nature of a large language model. It always creates one more word based on probabilities until it feels the response is sufficient and it's done with the response. That's all this is about. So when we talk to a large language model, to that kind of an AI, with that in mind, we can coax it into producing outputs that are useful for us. So that's an interesting thing to understand. How can we give it enough information where statistically speaking, a useful output is the most likely? That's what this talk today is all about. Now, we're not building our own models. That would be insane. We'd have to build data centers a mile long and a half a mile wide, and we'd have to spend hundreds of millions of dollars training these models. So nobody trains their own large language models. We are using the models that are out there. We are adding our own information. We know how to talk to them. Sometimes we have to give it a lot of information when we talk to it to get meaningful results. But that's essentially what it's all about. So we are using a pre-trained model. And yes, there is scenarios where you can fine-tune models, and these models are neural nets, and you have these neural net nodes, and the details don't really matter, but there's ways to take 99.999% of what's already there and train a few more nodes, essentially. So it's called fine-tuning. But we haven't seen, in our real-world implementations, we haven't seen the need for that. And the problem with fine-tuning and training is it takes too long, and in most business applications, you need to be up to date and have real-time data. So that's not a good way to go. So what I'm showing you here today has nothing to do with training your own model. It's using the models that are out there, and in particular, we are talking about OpenAI's ChatGPT, or at least the technology that's sitting behind ChatGPT, because in that sense, ChatGPT is only a tech demo for the technology it's based upon, which is the technology developers, which I know a lot of you are, can then use to build their own applications on. So that's what we're talking about is GPT. GPT stands for Generative Pre-trained Transformer. It means it generates text, it's pre-trained, and it transforms text based on statistical probabilities. Okay, so that's an interesting thing. It's put out by OpenAI. Microsoft is heavily invested in that. Just real quick, who is OpenAI? OpenAI is two different things. One is a nonprofit organization and one is a for-profit limited partnership. Founded in 2015 in San Francisco by, I think, a dozen people. Yes, Elon Musk was one of them, but he didn't see the future in it and left. And now he has nothing to do with it anymore. So the people that originally founded it are mostly still there. And Microsoft is part of it, has made an $11 billion investment into OpenAI, owns 49% of it. A collection of other people own another 49% of it. And the OpenAI organization itself owns 2%. So OpenAI plus Microsoft owns 51% of this, that have controlling interest, essentially. Okay. All the infrastructure behind this runs on Azure, and the infrastructure is insane. I mean, we're literally talking hundreds of data centers, some of them buildings a mile long and half a mile wide, hundreds of thousands of specialty hardware servers. Go back to my prior co-presents where I do an overview of OpenAI, where I show some images and some more information on how big this is, but it's mind-boggling, and nobody is doing this on their own. Now, that's the AI that we are talking about here today. That's the OpenAI stuff. There's other AIs. Many of them are very hardware intensive. Some of them are smaller. They're not as capable, but they may be capable enough for your needs. And you can even run them to some extent on local hardware, even though you probably need specialty hardware for that. But OpenAI is what we're talking about today. Then there's a special version of it called Azure OpenAI. You can buy OpenAI. It's a for-pay service. Might cost you a few dollars a month. It's not very expensive unless you do it on a very large scale. You can go buy that directly from OpenAI, or you can buy it through Azure from Microsoft. Why would you do that? Well, it gives you more than just OpenAI. It gives you infrastructure around it. It'll be charged through your Azure account that you already have. You can incorporate other Azure services like databases and cognitive search and so on. So in many enterprise scenarios, I find this very appealing, and I find it appealing that I don't have to go to yet another vendor. It just all comes through my Microsoft stuff, and it doesn't, Microsoft guarantees that they're not using the data for training, that my data remains safe. And I do believe Microsoft in that, because it's not Microsoft's job to retrain an AI. So I'm much happier giving Microsoft my AI queries or even my data, which I've already done for years, than to go to an organization whose main job it is to train models and who will always be tempted to use my data. So I'm happy using Microsoft, but both are viable ways to purchase this service. And then again, there's other players in this market that also provide language models. And also, as a little bit of a side note, OpenAI is more than just large language models and text processing. For instance, Dali is an image processing, an image generator. So this magazine cover that we ran here a little while ago was entirely generated and drawn and designed by an AI. So these two bears wrestling on a sheet of ice in front of the Aurora Borealis in a little bit of an abstract fashion was done entirely by an AI. A different AI that's not from OpenAI, called Midjourney, made this particular cover that we just recently ran in Code Magazine. Again, from scratch, drawn, painted by an AI. Now again, this is Midjourney, has nothing to do with OpenAI, but I'm telling you this for a specific reason, and that is there are many, many different AIs out there, whether it's for image generation, for language models, for all kinds of other stuff. And I do not believe that you will pick one and stick with it. I believe that your application should be architected in a way where you can incorporate all these different AIs. There isn't one AI that you use. Even within OpenAI, when you go to ChatGPT's interface, chat.openai.com, and you type something in and the AI responds, there's many different models. You can think of this as many different AIs that then respond based on need. So if you say, hey, answer this question for me, and it's just plain English, it uses one model. If you say, write me a novel, it uses maybe a different model. If you say, write me or analyze me some source code, it uses a codex model. So it uses different models in itself. And so I think an architecture that just says, I'm using OpenAI's ChatGPT 3.5 Turbo model for everything is not the way to go. You'll be using many different AIs, even in maybe answering a single question. I think that will be the case. So that's a fundamental architectural decision we made, as being open to using different AIs on a very, very granular level and letting them work together. So that's your first thing that you can take out of here today, is don't lock yourself into a specific AI. Another quick thing I want to mention here is Microsoft Copilot. We've talked about that a tremendous amount lately. Microsoft has entered this new era of software paradigms. So we've moved through GUIs and web apps and mobile apps, and now we have the era of assistant AI in the Microsoft world called Copilot. In other words, everywhere in your applications you have AI available, not for it to take over your work, but to assist in what you're doing. And that's referenced as Copilot, and every single Microsoft application will have a Copilot going forward. Some of them already do. You can go into Microsoft Edge's web browser, and there is a Copilot right in there, and we'll take a look at that. Now, if you want to see what's coming in the world of Office and many other things, go to this Reinventing Productivity URL that I put on there, or just Google or Bing, I guess, Microsoft Reinventing Productivity, and look at some of those short videos that are there. It's actually very impressive, and the impressive part is it's not just marketing fluff, but it actually works the way they present it. So it's already working today. It's just not being rolled out on a very large scale yet, because they're still building a lot of the needed infrastructure behind the scenes. By the way, I'm looking over here. I have my control center over here. And there's questions. I have people behind the scenes answering your questions in the chat, and they're passing them on to me as well. And there's a question, how do we get a job as an AI prompt engineer? What are some of the projects that we can complete to prove competency as an AI prompt engineer? Is there certification for that? There's no certification as far as I know. So what you do is you write sample apps, or you add it to the apps you already have, and then you do things like send it to me, because we are always looking for people that can do this stuff. Like I said, we are actually hiring in a very rapid pace, and so are many other people, right? So writing samples is probably the best course going forward for that type of stuff. Anyway, so that's Copilot. You'll also see that show up in Windows and in Power BI and everything Microsoft does. There's also GitHub Copilot. When most people, developers especially, talk about Copilot, a lot of people still think about this. And in fact, GitHub Copilot is absolutely amazing. It helps you write code, and it helps you analyze the code that you may have open in Visual Studio and Visual Studio Code. Very, very productive. Very good way to write better code than before. A lot of people are taking to this, saying here over 1 million developers. That stat is surely outdated by now. I know that a significant percentage of GitHub's revenue is now coming from this, which is amazing considering this only started a half a year ago. So that's cool, but this is not the only Copilot. A lot of people get that wrong. They think GitHub Copilot is the only thing we're talking about when we talk about Copilot. In fact, GitHub Copilot is a little bit of a special case that's cool for us developers, but we are talking about Copilot as a paradigm that will enter every piece of software. And I'd say it's probably the biggest paradigm change we've seen in the last 50 years, so certainly longer than my career has happened. We have some recordings in the Stata.net web. I think the last Stata.net webinar that we have a recording of. I'm showing some of that, and it's kind of cool. So I encourage you to check that out. So anyway, just to finish setting this part of the presentation up here, we pretty much believe in this statement here. All apps without generative AI features are now legacy. Let that sink in for a moment. It's a very strong statement. But the more time goes by and the more we see what these features and these systems can do, the more I think this statement is true. Unless you have assistant AI, a Copilot, some sort of AI that assists the user, I think your application will very, very rapidly become legacy. So if you are the 80% market share leader in your industry and you want to protect that, I think you need to build in AI. If you are the 5% in that same market segment and you want to leapfrog the 80% leader, build in AI, because if they don't, you have a good shot, possibly a once-in-a-lifetime shot at taking over that position. I think that's really true, and I think we see that in a number of ways already, where we just see how much more productive people are and how people want to work with those types of features. So, with that said, let's get into some specific examples around prompt engineering. And what is prompt engineering in the first place? It's such a large term, and it sounds like you need a 5-year engineering degree and all that. Prompt engineering is really just the art of talking to an AI. How do I send text to an AI and get back meaningful results? And that can be done by users, or it can be done by developers. And whether you're one or the other, you'll probably look at it in a little bit of a different way, because users just go to things like chat.openai.com or into Copilot, and they type in stuff, and they send in this prompt, as it's called, the question perhaps that they want to ask, or the task they want the AI to perform, and back comes a result. And of course, it's important to know how to ask these questions. And in fact, we are seeing that many of our customers, especially enterprise level customers, they now discover this need that they may have, 10,000 people working for them in their organization, or 100 people working for them in their organization, and they need to start learning how to use these features to be more productive than before and truly take advantage of it. So that's one part of it. But another part of it is that for developers. And developers have access to more than just a a single prompt, but developers can set up multiple prompts. They can tune how things run. They can set up chains of things. They can run invisible prompts that the user don't even see to perform secondary tasks. And today we'll talk about all of that. Okay? The basic concepts are the same. So as we're talking about this, it should be useful for both users and developers. So if you're in one camp or the other, all of this should be useful. At the end of the day, we have the statistical text calculator, which is all that an LLM really is on a very large scale. And we're trying to coax it into producing correct and useful results. And that's a key point here. It's fun to play around with ChatGPT and make it say funny things. But for business applications, of course, it's of paramount importance that the result is correct and useful. And we'll talk about how to make it do that. So what's the basic idea? We're sending prompts to the AI and we're getting something back. And that's also referred to as a prompt. So we are sending prompts back and forth. So as the consumer of the AI, whether that is a human or a piece of software, we're sending a prompt in and then we're getting a prompt back. That's the basic idea. And there's different types of these prompts. When you go to chat.openai.com, you type in your question and you have that one prompt available. But there's really other prompts as well. In particular, there's a user prompt that is invisible to you if you're using chat.openai.com. But as a developer, you can use that to fine-tune and set up certain things and set expectations and so on. And then you get back another prompt from the AI. It's called the assistant prompt. The AI is assisting you, therefore it's the assistant prompt. So most of what we're doing goes back and forth as these prompts. Yes, there's a few parameters you can tweak here or there programmatically, but for the vast majority of things you're doing is you're sending text back and forth. So from a developer's point of view, the world changes from using objects with properties and parameters to functions and very, very accurate definition of what you want with very specific expectations of what you get back, to just using language and having something that's intelligent enough to make sense of what you want to do. So that's what it's all about. And there's some questions online. I'll get to those later when they fit in a little bit better. So how do we get started with that? Well, one of the simplest things is to fire up a web browser. And I'm going to fire up Edge here. And I'm going to go to chat.openai.com. So I'm sure a lot of you have tried this, and I'm not even going to spend a whole lot of time in here. But I have signed up for an account on chat.openai.com, which is something I pay for every month. I therefore get access to a little more than the free accounts. You have two different options there at this point. You can use ChatGPT 3.5. That is the version of this large language model that came out last November. And it's currently the most solid model that we have. And then there's ChatGPT 4, which is considerably larger, considerably more capable, but it's also kind of a preview at this point, and sometimes a little rough. And they're still tweaking it. They're trying to put guardrails into place. Sometimes, you go in and it works perfectly fine, and then next week it's like, wow, it doesn't understand what it used to understand last week because they're tweaking it and they're trying to put in guardrails, and it's people all up in arms and say, oh, it's not working as well as it used to. And then you come back and another week later and all of a sudden it's even better than before. And so it's a little unpredictable. So GPT 3.5 is what we use more than anything else. But it's kind of fun to play with GPT 4 because it's just more capable. But it's also slower. And so we could now come in here and we could type in a text. We could say, I am climbing an apple tree and I am picking Anne. And as I then hit send, it will calculate statistically what the most appropriate answer to this is. Zoom in a little more here. And it'll then go on and give an answer. It says, well, we're picking an apple. The tree's branches swayed gently beneath me as the light breathed, and so on and so on. GPT-4 tends to be rather wordy, and there's ways of telling it how long we want it to go on. But that would be kind of the simplest version of this, right? And it goes back to what we said before. We're giving it some text, and it then calculates the next most likely word, which in this case is apple. And then it decides it's not done yet, and then it continues the same thing with the next word and the next word until it decides it is done. Okay. So question online is GPT-4 also trained up to November 2022? So GPT-3 is actually even older than that. I think it was, I forget when it was exactly, like we could actually ask, like here, say we go to GPT-3.5, when was I don't know, was your training cutoff date? And it'll tell us. So it's September 2021, right? And we could go and we could do the same thing with GPT-4, and then that's considerably newer, but it's not totally new, right? It's September, well, that's actually not even right. I think it's like September 22 or something. But anyway, the point is they're trained up to a certain point in time, and that's what they have knowledge of. But then again, you shouldn't think of a large language model as having knowledge. It's better to think of a large language model as being able to talk. And it's able to talk because it was trained on text, and therefore it coincidentally happens to have that knowledge. But that's not necessarily reliable, right? So that's an important thing to understand. So yeah, trying to zoom in a little more here. But anyway, so that's kind of the simplest version. Now, a slightly different version of this would be Bing Chat. Okay, Bing Chat here is built into things like Edge. I'm using the Edge browser, or you can just go to bing.com, and I'm not going to spend a lot of time on this. But the point being is you can ask it questions in here, and you can say, I don't know, what do you know about, oops. What do you know about platypuses? Now, the difference between this, and I know this is small, but the exact answer doesn't matter so much. I just asked it about platypuses. Now, what it does, it goes out and it searches the web first. And it takes the information from the web and it injects it into the question. And it then behind the scenes says, now go ahead and answer this question, not based on what you've been trained with. Just use what you've been trained with so you can speak English, but take the information that was just retrieved from the web up to the minute and ground your answer based on those facts. And therefore, it can give you up to the minute information on what's going on. So I could ask it, what's going on with the hurricane in Florida? And it would know right now what's going on with that, right? So the exact answer doesn't matter too much. Again, I know this is small, but just the concepts matter there. So that's kind of what the user would do. Now, as developers, we have other options. For instance, we can use the OpenAI Playground. So let's turn off our Copilot here, and we go to platform.openai.com. And when we go to platform.openai.com, we have this Playground button. Zoom in a little bit here. So we can click on the Playground. And now here in this Playground, we get a lot more leeway as to what we want to do. It's fundamentally the same tech as chat.openai.com, but this is now for developers. So I can come in here and I can type a message. So I can say, I am climbing the apple tree and I am picking. And so I'm asking the same question, but now I can specify exactly what kind of model I want to use for this. And I could say show more models, and we'll see that there's quite a few different models. Then I could set a number of parameters that'll essentially change the randomness of the response. Temperature is randomness of the response. If the temperature was 0, it would always respond the same way. If I set it to 2, it'll pretty much produce nonsense. So we'll leave this at 1. We can specify the length that it can generate and so on, right? So there's a few parameters, but the main thing is these prompts. Now note that there's also a system prompt over here. This is an invisible prompt that I can use to set up certain expectations. So I can say, you are a professional customer service representative. Answer in a short but informative manner. Right? That is how I will configure this system. Okay. So let me go ahead and let's trigger that. If I click submit, that's like hitting the submit button on the chat site, except now I've configured this to be shorter but informative and correct, right? So that's kind of interesting. So we did that. Now I could also say, you are a comedian, answer in a funny fashion that is as absurd as possible. All right, and now we get rid of that and we do this again. And we get a completely different answer because now we have configured the system with a system message that would, if we did this as a developer, would be invisible to the user. What we are looking at here is a developer playground. So this is meant to say, okay, as a developer, I could build an interface like chat.openai.com or build it into my application. And we want this to be hidden from the user. And this might be the question that the user asks, and then we get this answer. And you can see this is in fact absurd and funny. I didn't read through it. You can do that if you want, but it comes up with the weirdest stuff when you do this. Now, if you're a developer, you could now also go in here. Now you could say view this code, and you could see whatever. Maybe you're a Python developer. You could see how would I actually send this to OpenAI to programmatically do this. Okay, so this is just a playground, but we would use that as the basis for what we're doing. Now the question line, is it possible to add the Bing chat to an Outlook ribbon or make a channel in Teams for Bing chat? It's not currently possible, but in the next versions of all these applications, you will see that show up as just a Copilot feature. So you don't have to add it in any way as an add-on. It will just be there in every single Microsoft application. That's the future, and it's starting to happen now. Some people have the preview versions already. So anyway, that's the OpenAI Playground, and that's a really good way to play with this stuff as a developer. So I use this a ton just to try things out and see what happens. Azure has a similar thing. It's the Azure OpenAI Playground. You can use that as well. Now, it gets really interesting when you're a developer and you want to start interacting with this programmatically, and we've already seen the Python example, and I could bring up a simple Visual Studio example if you're a Visual Studio developer. Here's an example that I created. Very, very simple little project, just has a program CS file, and what I'm doing in here is I'm using an OpenAI client, which is an object, a package that Microsoft provides to me. So I've added in my dependency, I've added the Azure OpenAI package here, and I'm using that to communicate with a version of OpenAI that I set up on Azure. It's not the topic of today's talk how that works, but if you go back to my prior recording, I'm showing that in detail. But so I have an endpoint here on Azure that gives me access to OpenAI. And now I can say things like, okay, let's set up the system message. So in this case, I say, hey, you're a friendly and funny chap. Used to amuse an online audience. I like to do that when I do lighthearted demos. And you respond if you were John Cleese from Monty Python with an old English medieval way of talking, right? So that's my system message to configure the system. And then I just say, hey, type in some text. We will then use that as the user prompt. So I have an object that I can add these prompts to, and then go and call into OpenAI, pass it these prompts, so the system prompt and the actual text that was entered, and then see what the result is and echo it out to the console. So if I run this, here is my console window. Let me zoom in a little bit, and I can say, what do you know about platypuses? And it doesn't even matter if I misspell this a little bit, the language model will still be able to cope with it. And then it returns a response and says, my dear friend, I must say, I doth know quite a bit about the curious creature known as the platypus. And it goes on and it talks in the fashion of how John Cleese would talk. And it gives us a meaningful response, right? It's really that simple. Talking to this AI from a program is pretty straightforward, right? So that's nice, and we're gonna run with that. So question is, does ChatGPT test or validate the code it generates? So this, I'm not sure exactly what the question is. So the code that you see in the playground is really very trivial. It's just messages being sent back and forth, and so it just gives you the wrappers around that, and those are guaranteed to work. Now, if you are asking about whether the code that ChatGPT itself can generate as part of its intelligence, no, it does not. It just generates text like a programmer would, and then you could maybe ask it to create unit tests around it. But that's a whole separate topic around code generation with OpenAI. But for people who do not know what this is let me just show you really quickly. You could say, create some JavaScript that shows a message box. Right, and it gives us some information, and boom, here is the code that it thinks you need to do to show a message box, right? Now, does it actually test whether that's correct? No, it does not. It just generates some output that it thinks is correct. And sometimes it's right, sometimes it's wrong. It's generally useful, but it's not always right. But it's still useful where it's way worth using it. Okay. All right, quick side remark here. You saw that when I used the OpenAI Playground here, I ran with ChatGPT 5 Turbo as my model, as many other models. Rule of thumb, start with a relatively simple model and see if it does what you need it to do. There's a tendency for people to always try to use GPT-4, but be aware that these different models have different characteristics, both in terms of performance as well as in price. If you are running GPT-4, A, it will be slower, and B, it will be 20 orders of magnitude more expensive than running a GPT-2 model, for instance. Okay? So using the simplest model possible is very important, because you're really running up the tap very quickly. And if you deploy this in an enterprise where you have 10,000 users using this, it could get expensive, especially if you use the wrong model. So knowing which model to use is important. And there's a list of OpenAI models that you can use. There's other providers that are coming into the marketplace. There's also models you can run locally, which are then essentially free. So there's this Hugging Face community, Hugging Face website that provides models like that, and you can play with that as well. And in fact, one of the next co-presents we will be doing is showing how to use local models from the Hugging Face community. So stay tuned for that. Another concept we need to be aware of is that of tokens. When we deal with prompts, like in this case, we are passing a text, but under the hood, all AI is bad at dealing with text. All AI is good at dealing with numbers. So what it does is it takes all this and it converts it into numbers, which we refer to as tokens. And each model has a limit as to how many tokens it can deal with. And that counts both what I'm sending it, like in this case here, this text, and what it returns, in other words, this text, right? So that gives us a certain length, and we can specify what the maximum length is. Like in this case, where we're using GPT 3.5 Turbo, I can say I want a maximum response length of 4,095 tokens. That's what this model can do. Now, that's not entirely accurate because I'm passing in some text and that uses up some tokens. So if I just try to run this, it'll probably throw an error because, oh, it's too long. Because the response can only be so long, and it counts the input as well. Now, if I was to switch to a different model, like GPT-4, for instance, you'll note that the maximum length is higher because it can accept more tokens, and therefore it's also more expensive. So that is something you have to be aware of. So the question always is, well, what's a token exactly? Well, that's a little hard to say, but the best conceptual idea that I've come up with that helps me a lot, it's not totally technically accurate, but if you think of a token as a syllable, you get kind of the right idea. Now, there's a lot of people going to say, oh, that's nonsense, that's not technically right. Yes, it's not technically right, but it kind of gives you an idea of what we are talking about there. Now, if you really need to know how many tokens you're dealing with, there's tokenizers, and again, we've had some prior recordings that show how that works. We also do training classes on that. And I just wrote an article in Code Magazine that's coming out, I think tomorrow or the day after, which you can get for free on the website, codemag.com/magazine, where I show how to tokenize. There's just packages you can download. You can give it a piece of text, say tokenize it, and you get back a list of numbers. And then you can take that list of numbers, turn it back into text. And so this way you know exactly how many tokens you have. But so this is just something you need to be aware of. You'll be fighting this all the time. This token limit is the biggest pain that we are currently dealing with. It's a question online. It's does ChatGPT have a free API that can be used programmatically for learning or simple demos? No, they do not. But if you just do demos, it is super cheap. Like you will spend 28 cents or something. Or if you're doing a lot, like I do a lot of demos, I usually spend like $2 a month on that. But it's not free. And there's another question. You believe that all these AI features Microsoft and others are adding to their apps are sustainable and scalable? You mentioned paradigm shift. That's also a huge resource and infrastructure cost. And yes, that's absolutely correct. I think in the future we will see models that are more specific to a certain task, not as generally useful. I think we'll see models that are optimized for lower resource consumption. But it is clear that the way we are headed is we'll need more and more computing power to run this, and infrastructure cost and sustainability and power need. But hey, if we shut down all the Bitcoin miners, right, we have a lot of extra power for this. No, just kidding. But yeah, it's, that's the biggest problem right now. And what Microsoft's putting into this is incredible. Like we're literally talking about one of those enormous data centers. Like I said, the one in Dublin is a mile long, half a mile wide. Microsoft's bringing one of those online every 3 days, so 2 to 3 a week over the next year and a half. That's the scale we're talking about to make this possible. All right, one of the things I want to mention here, because I think it's an overlooked aspect, is this is not just about English, but it's about all human languages. The truly large language models are trained on all languages. So you can use GPT to say, hey, answer this question, but respond in a different language. Or I could ask it in a different language. So I could say, going back to my example here, let's get rid of these answers that we had. And I could say here, complete this sentence in Mandarin. And let's submit that. Whoops. A little bit smaller. Back to GPT 3.5. All right, that's complete nonsense. Get rid of that. And now, my result is being displayed, presumably correct, I don't know, in Mandarin and simplified Chinese, even though the question I asked was in English. Now, that in itself is very, very interesting. What this means is that you can do anything in your applications where you're using AI and make it available to anyone around the world in their native language. That to me is a tremendous benefit that you get out of this, because you could have an application that is entirely based on just the English language, but you then hire people who are more comfortable in, say, I don't know, Spanish or German or obscure languages, and they can say, oh, but respond to me in my own language. Or I want to ask a question in my language, but respond in English. I want you to generate some marketing text. Here is my Spanish question for you, and here's what I want to say, but create me some English output. This interchangeability of languages, to me, is probably one of the most overlooked aspects of these AIs and how I can engineer my prompt. So I have now kind of moved to a way where I say, okay, well, most of the time when I'm dealing with data, it's English, or when I'm dealing with documents, they're English. Therefore, when you ask a question, I don't care what language it is in, but first turn it into English internally, then I do my stuff, and then respond in whatever the desired output language is, and it just works. So that's kind of a really cool aspect that often goes overused. Okay. Now here is a kind of a related idea, obscured answers. Let me show you an example here of an application we are running internally. So I'm going to bring up a different project. And this is actually something that we have running in production. It's our internal application we use to manage our own business. So if you subscribe to this or you signed up to this event, the system I'm about to show you is the back office piece that goes with that. So let me just fire that up here in my development version. It might be a little bit slow, but shouldn't be too bad, hopefully. Okay, login popped up on my other screen. Let me log in and move it over. And this is actually an old Windows application that we have, and it's really slow at the moment. Trying to log us in, which is a side effect of me running my streaming setup here. Let's hope this doesn't take too long. Come on, wake up. Working. I don't know what it's doing, and it's on my other screen and I can't move it for the moment. Bear with me here. So what I want to show you here is basically our interface that deals with looking at customers. And what we have done is we've built a Copilot into that allows us to query customers in extremely sophisticated ways. If only my login screen would go away. I have a breakpoint somewhere. So we've built this AI, this Copilot into our system. And it allows us to do things like it allows us to say, hey, I want to look for customers that are our best customers, so abstract concepts like that. And we then want to be able to do things like give us customers that are also magazine subscribers or have applied for a job. And I really don't know why this is not popping up. Let me try this again. Okay. Log in one more time here. This is the development version. It's not very fast in general. And if it doesn't pop up, we'll move along. There is actually a recorded version that I've done in the past. But one of the key problems with what I want to show you here, other than it being really, really slow apparently, is that it's real data. And since it's real data, I usually can't show that in public presentations. So what I can do, however, is I can ask the AI essentially to obscure the data. So I can say, give me a list of customers from Texas who have these or that characteristics, and then replace all the information about the names of the customers with fake names. And apparently something is wrong on the back end here. I guess it's not getting to its APIs. But because it is smart, it can actually perform that task and then say, okay, well, here I have Bill Gates, but I'm going to show him as John Smith. And then I can say, well, what do you know about John Smith? And it then understands that John Smith is really Bill Gates, pulls out information about him, but obscures the data so I can use it for a presentation. And so I'm going to terminate this exam here because it's just not that important, but it's kind of a fun idea that AI is smart enough to do that sort of stuff. And again, there's a recorded version of this. I apologize for, it's a production app. I don't know what a backend so slow right now. But that's the idea there. And when it comes to this sort of functionality, the interesting part is that this is just emergent behavior based on the fact that it can reason intelligently, or at least appear that way. So I never built, as a developer, I never built into it that I wanted it to be able to do that. It just can do it. Just out of the box, all of a sudden this happens, okay? And this kind of complex reasoning is really amazing. And one of the samples that I always like to use on the prompt side for complex reasoning is what I'm showing here. This is kind of an example from human psychology. It's something that children of a certain age become able to do, and children before that age, when they're prior to that level of development, don't. So here's the example that we would like to ask, in this case, not children, but the AI. We have two boxes in a room, imagine that. We have two boxes. John, the first person, puts a ball into the first box. Now the ball is in box 1. He then leaves, then Bob enters the room, takes the ball from the first box into the second box. So now we can follow this reasoning, and the AI can follow this reasoning, and therefore we now know that the box 2 contains our ball. But now John returns later, John being person number 1, and as he comes back into the room, where do we think John is looking for his ball? Now we've determined that the ball is in box 2. That's the second level of thinking. Therefore, the simple answer is, well, we've understood that the ball is in box 2. Therefore, that's where he should look. But if we reason much more abstractly, not just follow where the ball is, but we then think one more level of abstraction and say, oh, but John thinks about this different, and he didn't observe that, and therefore we know that John thinks it's in box 1. That's a whole different level of thinking. Doesn't occur like, to us humans, it's natural, but that's a more complex level of thinking, and children only of a certain age master that. Now I asked GPT that, and here's the answer it gave me. John would most likely look for the ball in the first box, since that's where he left it, and he wouldn't know that Bob moved the ball. That's pretty amazing. How does it do that? We don't know. This sort of emergent behavior was unexpected that GPT 3, 5, or 4 could do, but it does, right? So it's almost a little creepy. But in a way, this kind of result out of the statistical math makes things like this prior example that I wish would have worked, possible, where all of a sudden it just knows how to do all these things. Okay, I've got some questions. I'm going to answer those a little later. Okay, so that's this emergent behavior, very, very cool stuff. I want to take this now a step further, and what happens when we go to ChatGPT here and we ask some questions like, what do you know, and we'll just use 3.5 because it goes a little faster, know about platypuses, right? And we get it to give us some answer here, blah, 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 lives in Australia, fascinating facts, it lays eggs, but is a mammal, it has a bill like a duck, but it's also venomous and blah, 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 right? So it gave us all this answer. And then I can say, is it dangerous to humans? Now, for this question to be answered with this it in it, right? Is it dangerous to humans? It needs to understand what the discussion was before that we talked about platypuses here in the first place. But it knows, right? It understands that we were talking about platypuses, and then it goes on and it knows that it refers to platypus and keeps answering the question. How does that work? We have to preserve that state somehow, okay? So state preservation needs to be done by the developers. And now we're getting into a developer-specific topic, and I'm going to bring up my prior example here again, which is able to do that, right? How does it do that? Let's run this one more time. This is my command line example here. Where did my command line? There it is. Okay, so I can ask the question here. And remember, this is the version that I configured to answer like John Cleese from Monty Python. So here it gives me that ability, and now I can say, is it dangerous? And it does the same thing. It basically understands that we are still talking about platypuses. The way this worked is that I actually take all my prompts, right? So now we're really talking prompt engineering. So the first prompt was the system message. It says you're John Cleese. Then the second prompt was the message I'm posting in. Then I get back the result from the AI, and I'm adding that to my pile of messages. And this is why it's so important that what I'm getting back from the AI is also considered a prompt. And then I continue my loop. I get the next message and I ask that, is it dangerous? And that just adds up. I'm adding message after message. And every time I talk to my chat here, I'm adding more messages. So if I ask another question, are females immune to the venom? I can see that my stack of messages here, which is small, but you can see here, we now have 6 messages in our list of messages that all get passed back and forth. So it's not that the AI remembers what the state was. It's that I give it the state every single time, so it has the whole history on every single request. And that works pretty well, and it therefore always knows what I'm talking about. And we're now passing back and forth an amount of text that's still well within the limits of what ChatGPT or GPT in this case 3.5 can handle. Now you will say, of course, at some point you now get to a point where you run out of space. And in fact, if we were to look at something like Bing Chat here, we turn the chat feature back on, you'll see that it gives you 1 of 30 messages in this back and forth. Because it does exactly the same thing, and there's only so much space you can use up. But we could actually do this a little bit better, and now we get into the interesting scenario. So let me actually take what we have here, comment that out, and let's move on to our next example here. And this is very, very similar in functionality. Let me run this. Okay, here's our prompt. Let's ask it a different question. Who is Obi-Wan Kenobi? Okay, and it'll have some level of knowledge about that. So it's like, oh, it's a Jedi Knight, blah, blah, blah. And now I can say, what is his favorite weapon? Now, in this case, in the first example, I passed all of this state back and forth all the time. But in this case, I'm basically using an example that prepares itself for running out of space. So I try to not make it run out of space. How could I do that? Well, an alternative to passing in the entire stack of messages would be to say, you know what? Just pass in this question, but rephrase this question in a way where everything that you need is already part of the question. How could I do that? Well, the question could be rephrased as, what is Obi-Wan's favorite weapon? Okay, so let's run this and see. And here it says, whoops, waited too long, I guess. Let's try this one more time. Awesome. There we go. So now it says, okay, well, I can rephrase this as a simple question that includes everything I need to know to answer this whole question and then produce a result. When would this be useful? This would be very useful when this is already very long. We are running up against the token limit, And maybe I could pass all of this in, but if we're already up against the token limit, then the answer has to be extremely short. But what if I want the answer to be elaborate and long? Well, then I would be very good if I could just send a short question like this and have all my tokens available pretty much for the answer. So how could I do that? How could I come up with this as the equivalent of this plus this, right? How could I do something like that? And the answer to that, as in many, many scenarios that involve AI, is that you simply ask the AI. Okay, so here is the code that does this. Okay, when we ask a follow-up question, so we have more than one question in our message stack already, then instead of just sending that question directly to the AI, I say, take all the questions, and then I ask it yet another question. Yeah, let me show you how this works. Oops. Okay, so here is the question that we want to send in. Let me show you this in the debugger. I'm gonna grab this and I'm gonna copy it out so we can see it better. I'm gonna open it in Notepad. Okay, so here's the entire thing I'm passing in now. There we go. So I say, this is my entire prompt that I'm engineering. I say, given the entire context of this conversation, turn the original prompt into a standalone prompt and preserve the entire context. Now I'm giving it the previous context, right? The original question, what came back, what's his favorite weapon, blah, blah, blah. Everything that came back from this. And then I say, what is the equivalent standalone prompt that does not require the above context for this prompt? And then I'm passing in the actual question. Is he force sensitive? And the result of that is that the AI will come up with an answer and says, here is the equivalent question. Is Obi-Wan Kenobi force sensitive is really the question you want to ask that doesn't require the rest of this context. And now I can use that and send it in and get an appropriate answer and have much, much more space for my token count in response. So that's an interesting prompt engineering technique, is letting the AI come up with better questions that do not require the same amount of context, right? And this is something to remember in very, very many cases as you are dealing with things that are hard to figure out, like, oh, how do I get from this to that? You let the AI do it. In many cases, it'll come up with a good answer for you. Okay? So that's kind of cool. And by the way, some of the tools that are out there, like LangChain, is one that's used by a lot of people, and it does some of the stuff out of the box, and they seem to then be very, it's treated like it's magic. It's actually very trivial, and there's, LangChain is pretty trivial to actually create yourself. Okay. Here is another thing that is very useful to do: summaries and abstracts. You'll see that all the time. You go to a meeting, Teams meeting perhaps is a very popular example. People talk, there's a transcript of it. Transcript is 50 pages long. You want to know what are the 5 most important points. The way you do this is you say, give me a summary of the following transcript. You paste in the transcript, you pass it all to the AI, it gives you back a result. Very, very straightforward. So that's what Teams does under the hood. If you've seen the Copilot in Teams, one of the key problems, again, is token limit. If you have large transcripts, you almost always are beyond the token limit. So what do you have to do? You split the transcript into smaller pieces, get a summary for each. You then take all the summaries, get a summary for that, and you continue until you got it down to a small enough thing that fits into the token limit and works very, very well. So I'm going to go into detailed example here. Related to this is extracting information from a piece of text. And this is very, very cool. Let me show you an example for that, because that's, I think, much more interesting than just creating an abstract or a summary. So here, for instance, I have an example, little piece of text. And this text comes, hypothetically, I guess, from a customer service engagement. A customer called up and he wanted to, in this case, book a vacation. Let me switch this into a slightly different mode so we can see this a little better. So here's the conversation. A user calls in and says, hey, I have some vacation time and I saved up $4,000. I want to fly out of San Francisco. Where could I go? And a customer service agent talks to them and basically sells them a vacation at a certain place, right? So with this, we could now use conversations like that. Let's say this conversation happens 5,000 times a day because we really are Expedia, we're one of those travel agencies, and we have all these conversations that happen all the time. And we now want to do something like extract information out of this. So we could say, where did the customer end up going? And we submit that. Oops. Let's reset that. There we go. And it says the customer ended up going to Japan, staying at hotel whatever from this to that time. So extracting information like that out of a larger prompt like this is actually very, very cool and useful. And it can do very interesting things. Like, for instance, we could say, what country or where was the customer from? It says the customer was from San Francisco, and that's absolutely plausible because he says he wants to fly out of San Francisco. Now we could also say, what country was the customer from? Because perhaps maybe we want to do statistics about where our customers are coming from, and it says the customer was from the US. Now that's interesting because there's nothing in here that says I'm from the US. But the model is smart enough to understand that he's from San Francisco. San Francisco is in the US. Therefore, the customer was from the United States. Okay, so that's pretty cool, right? So you can extract that sort of information out of your out of any text and then calculate interesting information from it. Question online: won't the prior conversation to the abstract that's being sent to GPT considered as tokens? In other words, aren't they tokens too? So going back to the prior example with preserving the state, the question is, isn't everything we sent to it considered part of the tokens? Yes, it is. That's the exact problem we have, that the length gets so large that the token count it becomes unusable at some point, and that's why we wanted to create that shorter version so we give ourselves more leeway again. Okay, so that's interesting, right? So this ability to extract information, even if the data as such does not occur in the source. Another example would be to say, was the customer happy? Maybe on a scale of 1 to 5, or just yes or no. Yes, the customer was happy, which is indeed true, right? He says, yes, I got everything I needed. So even if the information is not exactly in there, you can still do this. Now, another thing you can do is you can specify output format. Grab that out of my sample here. In this case, I say, generate me an output that includes the following. Okay, so now in addition to this conversation, we say, generate a summary of the below conversation in the following format. And I want, what was his problem? What is the outcome? What budget did he have? Where did he come from? Where did he go? And did he book a hotel? Okay, so that's the prompt we engineered here. And now you see that it does indeed fill in exactly the information that I requested above in that format. Right? So pretty cool. So it extracted things like the dollar amounts and the remaining budget and where exactly did he go to. And so that's something I could now almost use programmatically. If this is a program that makes this call, I'm getting back this text, I could parse this text and get the information out. The only problem is it's not necessarily quite consistent enough to really make this happen. It would be nice if we had even a little more structure. So one of the things I'm now going to do is I'm going to add this. I say, go ahead and give me the summary in JSON format. Okay, so that's the format I want back is JSON. So fundamentally, yes, I want the structure that I described above, but then turn that into JSON format. And now you see the result is now JSON, and that becomes very easy to parse in most languages these days. And now we have rigid structure that we can use programmatically in an old-fashioned way, and we could then simply say, okay, what's the budget? And we could extract that very, very reliably and easily. So a question online is, when we said, is that customer from San Francisco? Is he from the US? Could it be an incorrect assumption that the customer is from the US? And the answer is absolutely yes. It's just like think of this more as a human now, right? If a human looks at this and says, where is this guy from? Well, probably from the United States. It's not guaranteed to be right, but it's probably going to be right in most cases. And the AI acts in the same way. So we are entering an era of programming that's not necessarily as rigidly correct as it was in the past. Nevertheless, what we can get out of this stuff is so useful. It's orders of magnitude more useful than what we could do before. So it's just like we accept that humans are sometimes wrong, I guess. Now, there's some scenario where it must be right, and we could then instruct it to say, well, if you're not 100% sure, don't make it up, right? If it's not in the source material for sure, say you don't know. And that would be a system prompt that could tell us, or tell the system to behave like that. And so is this an example of where it's a hallucination? No, hallucinations are more where basically nonsense answers become statistically correct because there's no better statistical correct answer. But in this case, it was statistically the most likely case. So it's not a hallucination, but it's still not guaranteed to be right. But hallucinations are when it truly goes off the rail. Now, it shouldn't do that with this prompt here because we engineered this prompt with enough information and grounded it, as we call it, in real information where it shouldn't hallucinate anymore. So the problem of hallucination goes away in this case because we grounded it in enough real data. So, moving right along here. Oh, one of the things I want to point out that I did here, that's a very useful technique I find. I said at the top here, generate a summary of the conversation below. And then at the very bottom, I again said, give me a summary in JSON format. So I'm repeating myself. I repeat the question at the beginning and at the end. And I find that in the real world, that greatly improves the accuracy of the output. So it's a technique I like to use quite a lot in my prompt engineering, is repeating the question to improve the results. So good little trick to know. All right, now let's take this a step further and let's talk about how to inject data into an overall interaction. And this is really what you need when you build copilots. So the idea is the user asks a question, the AI can't know the answer reliably enough, so therefore it needs to go get the data. The data is then added as part of the prompt, just like we added useful data here, right? We added the conversation as part of the prompt. And then we say, now go ahead and answer this question. This is known as retrieval augmented generation, which has this somewhat unfortunate acronym of RAG. And to me, this is one of the most useful techniques that you can use in a business application that uses AI. Some of this is now supported out of the box if you're using OpenAI on Azure, and if you have some data in certain places like Azure Cognitive Search, you can hook the two up together and it'll do some useful stuff out of the box. Personally, I find it works better if I create this by hand and use it that way. Now, let me show you an application that we are currently working on for a customer who was nice enough to allow us to show this to you. So this is a work in progress, but it's actually already very cool. So let me bring up this example here. This is from a customer here in Houston that is an organization that helps homeowners associations. So they represent, I don't know how many homeowners associations in around the country or here locally. So we have a system that maintains information about neighborhoods. When does the trash get picked up? What are the rules? What are the architectural regulations? And so on and so forth. And we now want an AI that can answer questions related to that. Okay, let's hope that the login works this time. Okay, so here's this application. Now there is a front office and a back office piece to this. You can imagine if you live in a neighborhood managed by this umbrella organization for homeowners associations. If you lived in one of those neighborhoods, you may want to go to a website and say, hey, when is trash pickup in my neighborhood? Okay. What I'm showing you here is the opposite end of this. This is the back office piece. This is what the people in the office use if somebody calls up and asks the same question. Okay. So Windows application built in WPF. Again, there's a web piece to it, there's a mobile piece to it, but I'm showing you the back office piece. So what we could do here is we could go into this area of the application called Community Notes. And in the Community Notes here, we have all kinds of documents related to various communities. This is a sandboxed version, some test data in here, so the real data probably has more information. But let me bring up one of the neighborhoods that has a fair amount of information. And I could now scroll down here and I could look at information about the schools or whatever. So tons of information here. But we also have an AI here that's a work in progress Copilot AI. So the AI is not very polished at this point, so you have to bear with me, but the functionality is already pretty nice. So I could come here and I could say, when is the pool open? Now, when I ask this question, to answer this question, we need to take a few very interesting steps. First of all, we need to know what neighborhood am I in, what am I allowed to ask, security-wise, what is current information, and then find the information that pertains to this, and then figure out the answer. And that's what it does here. Okay, let me zoom in on that a little bit, and I temporarily improved or increased the font size a little bit. I hope you can read this. Let me move this. Ooh, what's happening? There we go. Screen sharing, I guess. So here is what the AI does, is I ask my question, when is the pool open? It therefore understood that it had to search the documents at hand that are in this case in SQL Server with a vector-based search index on top of it. It had to search all the documents that were relevant to answer this question. Then it answered the question. It says, the pool season is from May 1st to September 30th. Each month, specific schedule is released the month prior, blah, blah, blah. In the Cross Creek Ranch app, you can look at this or that, and this pool is open here or there, right? It comes up with a meaningful answer. And most importantly, this answer has to be right. And it is right because it's grounded in this information. In other words, we didn't just let the AI go out and answer whatever it felt like answering based on the pre-trained information. It is grounded in the information that is relevant, that applies to me, to my neighborhood, that I have access to in security roles, and that is currently active. Okay? And then it gives the answer. So that's important. And to make it even more confident, or make me more confident that the answer is right, it even gives me a list of all the source documents that were used to answer this question. And I guess I could then click on one of them and pop it up and verify it myself. So that's very cool. And that's a key characteristic for business applications. We have to get the answer right. Okay? So that's important. And then it also does kind of a cool thing here. It suggests follow-up questions. Hey, you asked about the pool. Here are follow-up questions. What are the hours for the Adventure Island pool during June and July? Because I guess it found that there was something special. So it understood that within the context we're currently at, Adventure Island pool is a thing that might be useful to me. Or another, it tells me about several different pools here. So that's interesting. How could I possibly come up with follow-up questions that make sense for each question and each context that I ask, right? Well, if we think about how would we do that in our program, it's an interesting conundrum, right? How would I do that? And the answer, as in so many cases these days, is you ask the AI to give you this as a suggestion, right? We're not programmatically trying to figure out what are good questions. We just ask the AI to do it. So let's take a look at some of the source code here that is needed to make this happen. Okay. So here is the code that goes into all of that. And what I do here is I have a service, a lookup service, which is basically an API that I can use to answer this question, whether it comes from this app, whether it comes from a mobile app, whether it comes from a website. They would all use the same service to look up this answer. So let's see. Come on. Let's see the implementation of this service. What is the name of this? There it is. So here is what we do. First of all, we send a message to the AI and say, okay, somebody just asked a question. Okay, when is the pool open? To answer this question, we need to now find documents that are relevant for it. To find documents that are relevant for it, I need to come up with a way to search for these documents. The way I do this is I'm looking at my search index. In this case, we happen to have a search index in an Azure service called Azure Cognitive Search. So I say, hey, you are helping me to create a search index. Provide a good search term for the following question. Okay, and then I basically paste in the question and say, give me a search term for it. But to make this reliable, you can use a technique, a prompt engineering technique called few shot. Few shot is a technique where you provide a few examples. That's why it's called few shot. You provide a few examples as to what you would want. So if the customer was to ask the question, what day is trash day? My search term would be trash day. If the customer says, when is the pool open? Search term would be pool hours. And then I say, okay, now go ahead and ask the question and come up with a good search term. Now, these are just random examples. And yes, I happen to be asking for pool hours. But I could have also said, what schools are in the neighborhood? And it would have then, in a similar fashion, come up with a result. So now I have a search term, and I can now use the search term to search my database. Azure Cognitive Search is a technology where I can pass a search term like trash day, and it returns me all the documents in my data that in some way have to do with something related to this. Kind of like you can ask Google for a result, right? So now we have our messages, we have our documents, and now we can create a longer block of information. So we can say, hey, okay, now that we have these documents, let's take all these documents and make a large prompt out of it. So the prompt is, answer the question below based on these documents. And I have a little bit of a scripting language here. I say, okay, go through all of my, where does it end? Go through all of my documents that I've retrieved and put them in a long text string with the ID, the title, the content, the actual article text, right? Iterate over all these articles. And I'm not going to go into all the details here, but I'm in our document, this is something we made ourselves, and you can do that as well. In our templating engine, we say, here is a block of text. If it gets too long, trim it at the end. Just put in as much as you can until you bump up to the token limit. And since a search engine like Google or Cognitive Search or Amazon Elasticsearch returns the most important matches first, we're going to eventually lose information, but it's less important, right? So we do that. And then we say, give me my answer in the standard answer format. Now, the standard answer format is kind of a cool thing. So let's see where this is defined. Come on, Visual Studio. So let's go search for that. Okay, here is our standard answer format. It says, format the output in the following way as valid JSON. Okay, first of all, in our JSON answer, we want the answer, which is standard output. We just tell it in plain English, right? Make a JSON piece that starts like this, then it has the answer, and we give it a little bit of instruction as what we want. Put the standard output here. Then add document references as an array. List all the documents you use to answer the question. So we gave it probably 50 documents. It may not have used them all. It maybe only used 3. But whatever 3 it used, I want the ID and the title of that document. That's important, right? Because now I know what it used, and I can then present that in the AI, in the UI, so people can go and check on the answer if they want, and I can present that in a variety of ways. And then, just because I think it's cool, I said also provide suggested follow-up questions. Suggest up to 5 related follow-up questions in this format. And so now this becomes one large prompt that has all of that in it. Then we ask the actual question, and then we repeat ourselves and say, now give me the JSON. And that is what gives me back everything that goes in here. We have the answer, we have the source documents, and we have the follow-up questions. And in reality, it wasn't all that hard. It was just asking the question the right way and asking it to provide not just the answer, but also the references and also the follow-up question. Now, you got to do it in one swoop because answers might be different every time, right? So you got to kind of do it like that. So that, I think, is very, very cool. You know, you can download the slide deck and you can look at all the different things that just went into that. But all these questions here are essentially about that. So let's see, there's a bunch of online questions. Which apps and tasks would you recommend using GPT-4 32K model with more tokens for? That's a very interesting question. I generally start out with a small GPT 3.5 model, and I only step it up if it doesn't do the job, because the GPT-4 model gets much more expensive. So just a trial and error thing. It's also, I think, fairly important when you build an app like that to build in some telemetry so you can have users say this was useful, yes or no, and then you save that away in some kind of log so you can then look at it and say, oh yeah, this doesn't always work. Maybe I need to change my prompt a little bit. So another question is, if I fed the AI my homeowner's insurance policy, would it be able to determine if specific losses are covered? Yes, it should be able to. You could say, you know, my roof just blew off in a hurricane. Is that covered by this policy? And it should probably be able to do a pretty good job at saying yes or no. Now, you should probably always then check where it found that, and you click on it and say, show me the section, and then maybe you read it yourself. But in most cases, most likely it'll actually do better than most of us who are not lawyers to figure that out. Question is, are integrations with knowledge graphs supported, or would that require custom coding? So knowledge graph could be something like the Microsoft graph. And if you're using copilots that Microsoft built, they go right after that knowledge graph. Currently, I'm not aware that you can manually do that, so you'd have to do some custom coding, but I think that's mainly a matter of time, right? This will change over time, and you'll be able, more and more vendors are making standard integrations available. Another question here is, how does my example deal with token limits? Wouldn't my collection of docs exceed the token limit? The way I'm dealing with the token limit is that in my templating engine, I made this thing called a trimmable block. Basically, I say, put all the documents here until you run up against the token limit. And then I'm just cutting it off, which in this case works pretty well because my documents are fairly small. And like I said, I'm using Azure Cognitive Search to retrieve the documents. Therefore, the most important documents are ranked first anyway and are the ones at the top of the list. If that does not work, I would have to do other things. Like maybe I would ask the AI to first summarize each of the documents and trim the unnecessary fluff out of it. That would give me a better result. If that is still not good enough, I may have to make multiple trips to the AI, consolidate the result, then make another trip to the AI and say, summarize it. And so you kind of, it gets much more convoluted if you have to do that, but it's doable. But yeah, that's really the hardest, most annoying thing you deal with. And of course, models are getting bigger and bigger, but none of them have unlimited is not feasible in a practical term, right? Because it just takes so long to answer questions then. The question is, then API or a method to integrate with the host that you're using Windows 10 or 11 to consult files for the whole system. So I'm assuming the question is, could you just have something in Windows that pops up and you ask the question and then it integrates with all kinds of stuff? And the answer to that is, it's coming. Windows Copilot will be baked right into Windows, and the code I have here could then be integrated into Windows Copilot, and then Windows Copilot could, if you have the appropriate security context, which is important and needs to be secure, and hence you do some custom coding around that, but it could then answer that question right in Windows Copilot. So you can envision a future where you bring up your start menu, but the start menu is not a start menu, it's a Copilot, and you just ask your question. And then, you could even question what's the point of an app at that point, and we're really heading off into a new direction. So, go back, already way over time again. Just a few quick things I want to point out here. Streaming versus non-streaming. When you use ChatGPT, you see the words are popping in like it's actually reading it to you. That's what we call streaming output. The advantage of streaming output is it looks a lot better in the UI. The disadvantage of streaming output is when you get something like a JSON result, now you need to wait for the whole result for it to be valid JSON. And so you just don't stream, you get the whole thing all at once. What I'm doing in a lot of real world apps today is I may split it. I may say, give me the answer as text, and then below it add the JSON, and then I stream it and I collect the output, and it starts to look much better in the UI as it trickles in and it looks like the thing is speaking to you. And then I get the rest of JSON, and then I put in, say, the references and the suggested questions. But in many scenarios, it's difficult with streaming. And in particular, if you need to get the result and you then want to check if the result is right, you very often need to wait for the whole result. So I think what's going to happen is that we'll see quite a few of these AIs to not stream the result as we know it in ChatGPT. So I want to mention that. Okay, here is another interesting prompt engineering technique that you can use, and I have a sample for that I created ahead of time. Here is an example where I say, calculate the speed of a race car. We're talking about a drag race. You're racing a quarter mile. It takes you exactly 10 seconds. How fast, assuming a few simplifications like linear acceleration, how fast would you have to go at the end of the quarter mile to go from 0 and then exactly take 10 seconds to do it? Now, when you do something like that, large language models are notoriously not very good at that. And then people go, oh, see, it's not all that smart, right? Humans are much smarter. And I'm thinking, okay, well, how many humans do you actually know that could do this off the top of their head in 3 seconds, right? But whatever, right? For computers to not be right about this stuff is not so cool. So what we can tell it to do is to use what we call chain of thought reasoning. Chain of thought reasoning basically says, think it through a step at a time and tell me about it. And since we are dealing with a text generator that always creates the next word at a time and then bases the next word on everything it's already created, as you're adding and adding and adding, and it adds this line of reasoning step by step, it is more likely to be correct at the end. So in this case, it came up with this result where it said, oh, I did this, and the average speed is calculated like that, and the relation between average speed and final speed is this, and therefore I'm using these formulas, and then you wanted this to be in kilometers and in miles, and therefore this is how I would do that, and thus the right result is this, which I haven't checked it. I'm assuming it's roughly right. But in any event, it is much, much more likely to get it correct if you ask these really complex things to be done in a chain of thought. So that's a good technique to know. And you just make it use chain of thought reasoning by simply telling it use chain of thought reasoning. Okay, so that's a good prompt engineering technique to know. Another thing that is an interesting technique is to then ask it whether it did it right or not. Now, this is a little bit of a future type of thing. This is as GPT-4 is being tuned, and sometimes it's a little, 1 week it's better than the other. This used to work a little better in the past, is currently a little iffy, and I think it's going to come back. But basically, if you let an AI generate all the output, and it generates it word by word, it hasn't thought it through until the end yet because it just generates a word at a time. So keeping this characteristic in mind, we can let it generate everything. And then we can say, hey, did you do this right? And then it has the whole result and it can check itself. And then it will very often, in GPT-4 at least, tell you whether it was right or not. And so like in this case, I said, did you do this correctly? Was the final answer in miles per hour correct? Please answer with yes or no. And it said, no, I didn't do this right. You can say, well, why not? And then it goes through it and it corrects it. And in this case, it actually turns out it's still coming out with the same result, but it just had some flaws in the line of reasoning. And then it said, well, I'm sorry, the reasoning was confusing, but the final answer was correct. But so this is an interesting technique. Again, it's a little bit iffy with the current generation, but I think in the future this may serve us well in scenarios where it truly needs to be correct. You simply say, hey, given everything you've just done, is this right or not? So that's an interesting technique to keep in mind for the future. Okay. Quick word about source code. You can let it generate source code in interesting ways. You can also let it analyze source code in interesting ways. So we're kind of getting a little bit into special case scenario, but let me show you something I did here. So I created, we as a company, we do a lot of legacy conversion, and we have tools that help us with that. And we have upgraded our tools to use AI to help us analyze source code. And so one of the examples is, here is something I did with Visual Foxborough code. So I say, analyze this Visual Foxborough code. The target audience for your answer is a professional software developer. We don't need basic answers. We understand we want to convert Foxborough code to C#. You don't need to explain the differences between C# and Fox. Just tell us about this particular piece of code. And then I'm giving it a piece of code And so here is that code, blah, 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 a fairly long piece of Visual FoxPro source code. And this is the end of that. And then I give it a little bit of extra information that turned out to be useful, right? So that's another prompt engineering technique. If you don't get the right results, give it a little extra information. So we said, when the use command appears, that's a good indicator in FoxPro that local data files are being used. That was an interesting piece of information for us. And then I say, answer the following questions in JSON format. And here's the output I want. I want you to tell me the cyclomatic complexity of the code, the number of commands, are the data access commands, is it accessing local data fields, which is a thing in FoxPro, does it connect to SQL Server? I want all lines of code that have data access commands because those are the hardest to convert. Give me a difficulty estimate of how difficult this is going to be to convert to C#. Why did you make that estimate? Explain what this thing does to me overall. And also, is there potential bugs in this? Okay, so that's kind of interesting, right? All the stuff that I'm just asking. And then again, I'm repeating myself, go ahead and do this. And so now here I get the answer. Cyclomatic complexity 7 is 42 commands, 13 of which access data. It's accessing built-in FoxPro data. It's accessing SQL data. Here are all the lines of code that access data. On a scale of 1 to 100, it's a 70 in difficulty to convert. Here is why it's difficult to convert. Here is what the code does. And it even tells us there's a potential SQL injection bug in that code because when the customer name is blah, 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 and it tells us about all that. That's mind-blowing when you really think about what this just did, right? The ability it has here is amazing. So what we have is we run this as part of our tools in a, this is a little bit of a simplified version of this, but essentially the same thing we run in our tools to analyze enormously large code bases and figure out what is the best way to go forward with this stuff and how long is it going to take and what's the most difficult part of it. And FoxPro is one such example. We do it with other legacy code as well. So that's an interesting technique that you can just ask it these sophisticated questions and we'll come up with an answer. There's a question online, can it reverse compile object code like IL code, I assume? It doesn't really reverse compile, but it understands IL. So it can actually take a look at IL and it can say, what does this do? Does it have bugs in it? Well, so it can. FoxPro is one example. IL would just be another language as far as GPT is concerned. Now, could you then ask it to make the equivalent code as C# source code or as VB source code or whatever? Yes. Now, it's not technically reverse compiling, but it's similar. It's not guaranteed to be as accurate as reverse compiling because it might take different routes to do something. But at the end of the day, the short answer is it can get to the equivalent. So the question is, if you have a large number of documents, how can you pre-process the documents so that you don't need to iterate with each new question? Well, you could, of course, just create some kind of loop that takes each document and then does things like say, give me a summary for that document so I can save it away for later use. And that may be worth doing if you know that, I have 100,000 documents and I need these summaries all the time. I don't want to do it a million times because it becomes too expensive. Now, if your scenario is I have 100,000 documents and likely people are only going to look at 10 of them, then it's better to do it as needed because you've just processed almost 100,000 documents and paid for that. Then it's probably going to cost you $5 or something that's not hugely expensive. But if you do it for no reason, then it may not be useful. You have to make a case-by-case judgment call on that. All right, well, that pretty much brings us to the end. Here is another thing that I want to mention. Functions are an interesting side note here. They're not technically prompt engineering, I guess, but you can set up calls to an AI where you say you can also call these functions instead. So let's say I have an AI that calculates the speed of my race car. I could say, if you're dealing with race car acceleration questions. Here is a function you can call, and here's the 5 parameters you need to pass in. And the AI would then be smart enough to figure out, oh, this is about race car acceleration, therefore I can call this function, and it would return back and say, here's the function you need to call, these are the parameters, go call that function essentially and calculate it, and then that gets considered as part of the result. That's just a little side note. You can configure your systems like that, and we'll probably cover that in a future Code Presents presentation. All right, but this pretty much brings me to the end of this. Again, I'm already way over my time, which I apologize for. I really thought this was going to be a little shorter. But hopefully this was very useful to you and you saw some real-world examples. We can fill 5 more of these presentations with more content. I was hopefully able to scratch the surface a little bit. If you have any questions, feel free to contact us. Like I said, consider us a resource. Happy to do an executive briefing for you. I know, again, we do like a free hour of consulting, so it doesn't necessarily have to cost you anything depending on how large your questions are. So consider that. A few other announcements. Again, this talks about the executive briefings. Be happy to do that for you. Staffing, we already talked about that. If you've any needs for staff, you're looking for a job, right, contact us. Check out the training classes that are coming up. We will have, in the near future, hands-on training classes where we spend all day on diving into these details. These training classes are scheduled. They will, before the end of the week, make some more announcements on our website. We can also do them for you specifically at your organization. So most of the training we do these days is we go to companies, enterprises, other software companies, and train their staff on their specific needs for AI and other things, like we do security classes and all kinds of stuff. So consider that. Also, again, we are scheduling a variety of free additional events and webinars and in-person events that are all dealing with AI. Pretty much it's all AI these days, right? Even when you talk about Azure or .NET, it's pretty much all about AI because that's the world we live in. So take a look at the State.NET website and the Code Presents webinars. Probably before the end of the week, we'll have the next series of free events announced up there, okay? And again, slide decks, recordings will be available for download. We'll send you a follow-up email, but you will also be able to find it at these URLs. And also subscribe to our YouTube channel because more and more of our video recordings are being made available there for free. And again, could do me a huge favor if you could fill out your survey. Tell us the kinds of things that you would like to hear about. And it helps us just to decide what the topics of the upcoming event should be and what we should spend time on. So doesn't take long. We're giving away a $100 gift certificate for that. If you turn it in by September 8th, I guess, midnight, that's when we'll raffle off the certificate. So all the surveys that are in by then are going to be considered. And that brings us to the end. I'm going to stick around a little longer. There's still a few questions online that I haven't answered. For the rest of you, thank you very much for attending. Hope this was useful and hope to see you either at one of our live events or one of our next webinars. So let me go back to the questions here. How would you create a subscription model to get access to that specific data? We'd have to take that question offline. I'm not sure what you mean exactly by that. And what if the documents are private? How would you have the AI examine the docs? Well, like in all the examples I did here, the documents are private. They're stored in our databases, our data stores, and our Azure accounts. So the key is you retrieve the document and you actually take the document content and you pass it as part of your prompt. So your prompt becomes very, very large. You just pass it in and then the AI answers the questions on that. So they remain private and you pick only the ones that are necessary. Could there be a security issue putting a bunch of code into ChatGPT that could have company IP in it? Absolutely. If you take your code and you paste it into chat.openai.com, that will not remain private. That is part of what they use to train the AI. And there was the very well publicized case with Samsung, where all the Samsung engineers pasted their code into OpenAI to tell it whether it was right or not. And within weeks, all of a sudden, OpenAI's ChatGPT started generating code based on Samsung IP. And that, of course, was not very good. So if you're using the free stuff, then yes, it'll absolutely be used for that. That is why you want to use an enterprise-ready version of this. If you're using Microsoft's version of OpenAI, all the Azure stuff remains private and is guaranteed to remain private. And just a few days ago, OpenAI announced their version of their enterprise ChatGPT, and that's also private, and it's made for that. And also if you're using their APIs, but you have to pay for that. So make sure you use an enterprise-ready version of this. Everything that's just chat.openai.com is not private, so be very aware of that. And there's a question about an automated quiz. Like, could you make an automated quiz, an interview question with multiple choices, and then have ChatGPT rate it? And yes, that would absolutely work. That would actually work quite well, because if you are creating interview questions and you're rating the answer, statistically, the correct answer is the right one. And so it will have, based on statistics, a very good way to rate that. That's also why ChatGPT is good at it itself passing interview questions or passing the bar exam for attorneys and all that, because statistically the right answer is the correct answer. So that's the answer to that. And yeah, I think with that I answered all the questions. Again, if you have questions, feel free to send me questions, send it to info@codemac.com. I am sometimes a little slow because I'm overwhelmed with email. So if you're sending it to info@codemac.com, it might be answered faster, but I do promise I will eventually answer all your questions. And again, if you have bigger questions, most likely our executive briefings, our free hour of consulting is your way to go. So thank you very much. Again, apologies for going way long. But hopefully the information was useful to you. Thank you.